All right, welcome back. Let's talk about folds. So if I have a layer of rock, right, what type of stress could cause it to fold up? Tensional stress, where I pull apart? That's not folding up anything. Shear stress, where I kind of move side by side? That's not doing anything. What about compressional stress, where I push inward? Oh, that seemed to fold it up. All right, maybe sometimes they fold up. Maybe sometimes they fold down. Maybe sometimes they only fold one way and all crooked. So what type of stress could cause layers of rock to fold? It's always compressional stress. So folds are any bends or warp in a layered rock. Again, caused mostly by compressional stress, mostly found in sedimentary layers, but again, any rock could be susceptible to this. But sedimentary rock layers tend to be a little bit softer, a little bit easier to bend with a little bit of heat and pressure. But you can still do it in other types of rocks. Multiple folds, kind of different types, kind of back to back, are usually found next to one another. And we'll talk about these different types of folds. So you can see it's kind of the layers here of rocks are folded up and folded down, and they're kind of folded back up. Maybe off screen they're folded back down and back up and back down. So these are actually different types of folds, but they're usually paired, or not even paired, but it can be a bunch of them, one after another. So now we're talking about ductile deformation as a fold deformation. It's not elastic, because then they would snap back, but they're folded enough to where they stay like that. They don't break, they're just folded, so therefore ductile deformation. The conditions in which you would get this, again, what you're going to see here is in general, there's always exceptions, but the typical conditions are where rock's a little bit hotter, so therefore deeper down below the surface. The warmer a rock is, the easier it is for it to bend. Pressure or force, a lot. Whether it's a fault or a fold, you need a lot of pressure. Rate of deformation, in this case, rather slow. Faulting fast can break, but actually rather slow deformation. As far as composition, any, but more commonly seen in sedimentary rock layers. So there's actually 5 different types of folds. The first is called an anticline, a fold in which the form of an arch with the rock strata pointing upward, and you have the oldest, well, I'll get to that in a second. So you get some sort of upward folded rock. So when we're looking at folds, we're looking at the sides. We're not necessarily looking at what's on top, but the cross section. If I were to slice the earth and look at it from the side, what would I see? So from the side, I would see kind of this up and down. The way I remember anticline is like a capital A is formed like this. Anticline is kind of arched up. On the surface, if it was eroded down, what we would see would be older rock layers in the middle, and as we get further away, the rocks get younger and younger and younger. So that's surface geology, interpreting what's below ground. We'll touch on that in lab a little bit. So again, the exposed layer on the surface is the oldest, but from the side we see it kind of up and down. Here's a great example of an anticline, up and down. Again, to me, like a capital A almost. Right? So there you go, up and down. The opposite of an anticline is a syncline, folded down and then back up, forming a trough. That's what you would see from the side. On the surface, if it was eroded down, you would see younger rocks in the middle and older rocks as they get further and further away from the center fold. More on that in lab again. Again, the exposed center layer is the youngest. So again, what you see here is down and back up. This is just how I remember it, but the way I remember syncline is that in some religions, if you sin, you go down to hell. And so what I imagine is that it's kind of pointing down. This is like the tip of an arrow pointing down, syncline. That's just how I remember it. Then you also get something called a monocline. Mono, meaning one. It's the simplest type of fold. It involves a slight bend in otherwise parallel layers. So you get flat, 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 bend up, flat, flat, flat. Or flat, 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 bend down, flat, flat, flat. So it just kind of goes horizontal, bends up, and then goes horizontal again. So there's not up and down, down and up. So monocline, just one. So here's an example of a monocline. You got some layer kind of bent up, and then it goes flat. So just one bend to it, monocline. As mentioned, with these folds, you typically get a bunch of these back to back to back to back. And that's a great example of that would be the Appalachian Mountains over off the east coast of the United States. The Appalachian Mountains formed due to a collision of continents as supercontinents were forming, Pangea, crumpling and rumpling up that portion of what was to be the United States. And so that compressional force, remember all folds, compressional force, kind of folded up where the Appalachian Mountains are now. I will say this, not all mountains are formed this way. Not all mountains are anticlines, synclines, fold. No, that's not the case. That's not the case at all. All right, so get that out of your head. It just so happens the Appalachian Mountains are. Now, what's tricky is the following. In the Appalachian Mountains, just because you see a mountain peak, that doesn't mean it's an anticline. We're looking at the geology from the side. So sometimes, as weathering and erosion take place, so looking at an eroded anticline, here's a great example right here. So this is what's now a mountain peak, but it's still a syncline. All right. So the geology from the side, when we're looking at folds, we're looking at the geology, the layers from the side. What's going on the surface, whether it's a peak or a valley, a mountain range or a valley, you got to be careful. So you look at it from the side, or we look at the surface geology looking at the ages of rocks. Okay, so you got to be careful. You got to be careful. So for instance, this is a valley. If you were just looking at it on the surface, you're like, oh, it's arched downwards, the syncline. No, the layers are actually arching up and back down. That's actually an anticline underneath the ground. So you just got to be careful. Here's the Appalachian Mountains. Just an image to show you how they're kind of all folded up. A bunch of mountain ranges all folded up. So excellent geology, old mountains over there in the Appalachian Mountains. But again, not all mountains form this way. You got it? Rocky Mountains did not form this way. A couple more types of folds, but this time in more 3 dimensions. You get domes. So domes from the side, from the geology, from the ground geology cross-section from the side, kind of resembles an anticline, but it does so in 3 dimensions. On all sides, it looks like this. So the layers dip uniformly away from the center structure, where you have the oldest material in the center, youngest on the outside. More on that in lab. So domes are caused by compression and uplift. Sometimes there's something below causing this to kind of dome up in 3 dimensions, a magma chamber, sometimes pressure from all directions, sometimes layers of salt or other hard resistant material causing this. So very unique, somewhat rare. Your folds, anticlines, synclines, monoclines, much more common than domes. Here's an example of a dome, satellite image looking straight down at a dome. You can see its layers eroded away from the center. The opposite of a dome is a basin. So from a cross-sectional view from the side, it kind of looks like a syncline, resembles a syncline, but you'll see that in all directions. The layers dip uniformly in all directions to the center of the structure. In this case, would have the youngest layers in the middle, oldest layers on the outside if it's been eroded down. It's caused by compression and down warping. Sometimes it's because material left underneath. Magma chamber went away and that material kind of dipped down. Or some other material was eroded and it caused it to dip down in 3 dimensions, creating a basin. Again, kind of unique, kind of rare, but they do exist. This is looking at the Tanzaruft Basin in the Sahara Desert, looking straight down at some eroded layers. If we could ascertain the ages and figure out where the youngest materials, oldest materials, we could see that this is a basin. More on that in lab. And then you have something called plunging folds. Plunging is the tilting of the fold towards the front or towards the back. All folds typically have some degree of plunge. Plunging is a characteristic of a fold. It's not a type of fold itself. It's not like anticlines, monoclines, synclines, plunging folds. No. Plunging fold means the fold has just been kind of tilted one way or another. So here is a fold. Do you know what type? Arches up and back down. Looks like an A. Anticline. So that's the fold itself. If you were to just tilt it a little bit to give it some plunge, it looks like what we see here. And most folds have some sort of plunge to it that we can see. So here, again, some plunging anticline, plunging syncline, what those look like, etc. Again, they're not a distinct, different fold. It's just the tilting of a fold gives it some plunge. So some awesome examples of folds. Let me show you that, but before I do, let me give you the last part of the super secret code. It is the number 6. You got me? The number 6. Let me say it one more time. The number 6. Here's some just cool folds from around the world. Nothing you need to memorize here or remember, just some cool stuff to look at. Here are some folds in Greece. Here are some more folds in Greece, kind of more to the sides. In Maryland, here's a great example of, here's a mountain, but yet the cross-sectional layer shows us actually a syncline. Excellent example here. France, a little bit of everything going on. Look at this, from the side, all these zigzags, crazy stuff. In the UK, Canada, wonderful anticline paired with a syncline. Awesome stuff. Mauritania, here's a dome or a basin. Some more folds in Namibia, looks like kind of more of a tilted syncline. Israel, I don't even know what's going on here. I see folds, I see faults. There's a little bit of everything going on here. Some craziness. So this is a shorter unit. Let's wrap it up. So some of the big ideas as it pertains to folds and faults. The 3 different types of stress: compressional stress, tensional stress, shear stress. How those play a part in faults or folds. What are the 4 factors that affect rock deformation? There's temperature, rate of deformation, etc. Also back in section 1. The 3 types of faults and associated stress: normal, reverse, and strike-slip faults. And the 5 types of folds. And there's, remember, only one type of stress associated with all folds. And those folds: anticlines, synclines, monoclines, domes, and basins. That's it. That's all I got. I'll see you next time.